Good morning, everyone. This is Bruno from Fanuc Technologies. Thank you for attending our third and final webinar for the series in Automation Studio version 9.0. So let's get things started. So as some of you might be aware from our last two webinars, this is the list of the three webinars that are included in this series. So today we're looking at the fourth webinar that we have today. The other two webinars have been recorded and will be shared with all registered participants and posted on Fanuc Technologies website. So these are the topics that we'll be covering today. So we'll be the P&ID and the robotics workshop. For all questions, please use the questions box during the webinar. We'll try the best to answer your questions using the Q&A tool over the course of the webinar. Please note that the webinar will be recorded, this one as well, and also posted on Fanuc Technologies website. So without further ado, I'm going to pass things over to my colleagues so we can get started with today's presentation.
Thank you. And let's start with the introductory topics for today's webinar about new technologies or new workshops available in Automation Studio 9.0. So the first one of which is P&ID, or the Piping and Instrumentation Diagram module. So this is a feature that was added. So it's a new feature that was added for 9.0. And the goal with the feature is to create P&IDs, so piping and instrumentation diagrams. In the software, they are available as a separate document that, of course, uses its own library. So to access it from the interface, so it will be a matter of handling as a new document. So like any other technologies, for example, there is here a new type of document called instrumentation and process control diagram. This was made to make it as generalized as possible, but it's what you would call a P&ID. So it's to create piping and instrumentation diagrams. So there are options like do it from here. There are also templates that are available with the software that already have been, I would say, prepared or pre-programmed to comply or to incorporate many details from different standards. So in this case, for example, it would be the ISA standard. It's the 5.1 version, the latest available, which is 2009. So this module, of course, has its own specific library, and that's available right here. So the library here contains different symbols that are not, I would say, that are completely new in the sense that are based on ISA standards for the identification, I would say, the symbology of components. So for example, your instrumentation, they would look like this. Valves look a little bit different, uh, which would be what you would normally find on a P&ID. So if you are used to using the software, for example, for drawing using hydraulic or pneumatics or something like that, so the symbols are quite different. Now, this P&ID module, it's, I would say, the first release of this feature. So it's still not a fully, I would say, there are still things that are needed to develop here. And of course, we're working towards that and will be added in future versions. So this first release of the feature, the target audience is mostly for schools. So the idea here is to get students to interact with different components on a P&ID, interpret a P&ID, understand how things work on a P&ID, and so on. But for professional use, still not at the level that I would say an experienced user would expect. As I said, this is something that we're working towards in the next version, so we'll be adding more capabilities to this development. So how to work with the P&ID? So it's the same as like any other technology. So you would have components from the specific library. So small distinction, because the symbols are very similar, we have decided splitting this library into two main categories, so liquid and gas. So this is the way that works in the software. So this is one of the current limitations, at least for the time being. So if you're creating a schematic that involves multiple streams, you will need to keep those phases separate. This is probably something that we're going to address in the future, but it's what we have at this time. So symbols for liquid, symbols for gas, so they need to be handled separately or connected the right way. Now, the schematic, of course, this new document type, as always, work the same as the other one. So you can drag and drop components, for example, things like this to create your schematic. So the symbols look a little bit different. So they are a little bit bigger. If I zoom in here, you will notice that these are the lines are thicker than in other compared to other diagrams. This is part of the ISA requirements or other related standards for drafting PNIDs. So we already take this into account. Now, this to complement the things that we don't have in the library for the PNIDs, users can complement their schematics with other technologies. So for example, hydraulic schematics. So this new PNID document accepts hydraulic components or is compatible with them, pneumatic as well, even mechanical objects from the mechanical library, and even some control type of objects, so signal generators and things like that. So everything here. Now, and related to this, of course, the main goal of PNID is to document your pipes and your control loops. So the PNID library comes with a bubble subsection, as it's called on the different standards related to the instrumentation. So again, in this iteration, this is, I would say, minimum capabilities. The idea here is to get the target audience to be familiarized with the how to create the PNIDs, what they're used for, and so on. So, of course, this is something that will evolve quickly in future versions in the software. So, more extended capabilities for these components for the instrumentation part. Now, the way they work is a little bit different than probably you're used to. So for example, if I create a very simple circuit just to illustrate how things work, so we could, for example, have something, a pump that transfer flow from one part of the system to another, and then it's just connected here. It's protected by a relief valve, for example, typical application. So nothing gets more simpler than this. So if we look at the valves here, there are some already available like that. So you will notice, and this I wanted to bring your attention to, is how the construction of the system is a little bit different than you would expect. So this is part of the requirements of the ISA standard. Main flow lines need to depict, for example, the flow direction in the sheet itself. So on our case, in edition mode, you will be able to see, for example, these kind of lines. Of course, we would need, for example, if we want to protect this line, but we could create a little point there and then just connect the line correctly here. So like so. Now, to get rid of additional unwanted arrows and things like that, there are new extensions that were added to the interface, specifically in this document, for example, to control these objects. So, for example, any lines, there is access now to the arrowheads and both points, but also the middle one. So, for example, let's say in this section, we don't want to showcase the middle arrow direction, but we can just simply turn it off locally and so on. Now, this brings us to another improvement here. So we have added ways to represent different type of lines. This you will typically find on a PNID. So when you have your instrumentation, so there are lines used to depict signals. that involve how the signal travels from one instrument to the other. So in the software, we have added these such lines. So for example, I'm going to do this here quickly. So of course, we would have the process line, the main process line, which is a thicker line. So secondary type of line. So these comes specifically from the different P&ID standards. Instrumentation, just to give you an idea what it looks like. So it's a little bit thinner. And of course, auxiliary, a little bit thinner as well. Now, when you get to the functions of the signals, there are, I'm just going to move this around so we can see. So these patterns of objects that repeat over the line. So these could mean different things. So for example, this is a hydraulic signal that can go from one instrument to another. Of course, liquid, capillary liquid looks like this. And of course, a pneumatic signal can look different also. So for this, we have added an improvement on the line feature that is accessible in this version. So for example, if we look at the line appearances here, now there is available something that we call a periodic pattern, which can be used to depict these kind of symbols that represent different signals traveling on a system. So again, the need for this was for P&ID, but it's available in other technologies. So I'm just gonna go back here and then restore this the way it was. So of course, this schematic also supports simulation. So we see the schematic in addition mode, like I have now. But the goal of a PNID is it's also would be in this case to validate a control loop or something like that we have implemented just to see if we need to make some adjustments or modifications. So this would be able to be validated in simulation. So something simple as that. So we can have access to the different tools that are available to measure parameters in the system. Of course, seeing an animation of what's going on. For example, measure the flow, measure the pressure, and things like that. So, for example, if we measure the flow, we would be able to see how much flow we're going here. So these, of course, would be able to change. So this has not changed from other capabilities of the software. So it's been extended to this type of diagram. So the idea here would be to create schematics to depict instrumentation. So I have an example here that I can show just to illustrate what this would look like. So this would be for a pasteurization process. So in this case, we have a selection of different fluids that are available. Of course, in future versions, more will be added, but for example, in this case, it's a milk pasteurization process that we're depicting here. So milk can be approximated as water for fluid properties point of view. So the idea here is to create a simple circuit, that depicts all the instrumentation, how the flow is going to the system and so on, and of course implements the logic. So we see here the control valves, the controllers for the different parts of the circuit. So for example, controlled signals that are tied to specific valves and so on. So in simulation, we would be able to analyze this to see if we need to make adjustments on the control loops and things like that. So I'm not going to let it run very long, just to give you an idea of what can be made. So typical PNID. In future versions, of course, more features will be available, but this, as I said, this is an introduction or a first release. So it's to present the feature as well. Now there is also available let me return back to my empty project. So there is also available, since the target audience is school, we have made available an illustrated library to create circuits for the teachers, for their students. So for example, to create level control circuits, pressure control circuits, flow, temperature, and so on. So there are different type of objects that are available here. So pressure, for example, we see instrumentation that might be more in the lines of what you would see out there in the field. So, for example, this would be a pressure transducer or a level transducer, things like that. So, valves, pumps, and so on. So, for example, liquid valves of different technologies, so diaphragm valves, electric valves, and so on, and even pumps. So, centrifugal pumps, or gear pumps, things like that. So the idea would be then for teachers to use these technologies to create, for example, a schematic that looks like this. So a graphical schematic that still features simulation that will be able to use, for example, to teach students how to analyze this kind of circuits, program a controller, things like that. So in this case, we're looking at an implementation of a two-part control, so level and temperature. So we're controlling the level on this tank and also the output temperature here. So we're mixing cold and hot water just to feed a hypothetical service here. But the idea here is to use the tools to see this in simulation. So that's it. I hope this has been of interest to you, and I'll pass the torch to my colleague for the next part of the presentation. Thank you.
Okay, great. Thank you. So for the robotic workshop, we start with this demo file where we can see uh, the 3D environment with the robot and object, and in orange the path that the robot will follow. So this is what we will see and what we can do in the robotic workshop. So define a path for a robot to move across different objects and act. Do some actions. So if I start the simulation of this project, we can see the robot moving on that angled plane following that flower shape. So if I start from a new project, I have to create first a robotic document. So here I have my robotic diagram. You see I'm in the 3D environment now. And from the generic library, I can take robots. We have a 6-axis and 4-axis robot. And then we can place the robot in the work cell. So there it is, my robot. I can add a tool to the robot by simply, we have 3 tools: cylindrical, conical, and a section tool, for example. So I can simply take the tool and drag it over on the robot itself, and releasing it, it will appear at the end of my robot. If I want to change the tool, I can, for example, take another one and do the same operation. For the tool itself, we can define the, for example, the dimensions of the tool. So let me, for example, change, I know, the height. Let's make it a little bit shorter. And you see that my tool at the end of my robot is now shorter. In the robot properties, I can define many parameters, but right now I want to focus more on the work envelope. So I can display my 3D work envelope, and I use the tool center point. So we can see the work envelope, so this sphere where my robot is capable to operate, so where the space where the robot can reach. And I will insert a couple of objects for my robot to work on. So for example, I can place a cylindrical object in my uh, work envelope and a cubic object on the other side. So my objects are inside my work envelope, so I can now remove that envelope display so we can see the environment better. I'll also change, for example, the color of my objects. Let's make it blue like that. And as well, I can also rotate this cube a little bit, for example. So once I have defined my robot and my objects, um, I can start thinking about programming the robot itself. So to program my robot, I can go in my robotics menu, Motion Program Manager. In here, for my robot, I can create a motion program. So my motion program will define the movement of the robot. In order to do that, I have to define first some points, so some waypoints for my robot to reach. So for example, I'll add a new waypoint. So when I take the action of creating a new waypoint, I have here my control panel that appears, with which I can jog the robot, the different articulation of the robot, and move the robot, for example, in a specific coordinate. So this way we can move and place the robot in all different positions. I then have also a couple of quick shortcuts to go back to my own position. So let's save first the home position point. So this one will be my home position. And now let's go take a point on the cube and on the cylinder. So we have different ways to select a point. For example, I can, using this button, I can select the center point of a surface. You see, so that's the center of my cylinder. And I can save this position. Let's call it cylinder. I can also select a point on the edge of the component. So for example, I can go select my edge on the cube. And I want also to rotate a little bit the tool on this edge. So I can select this dragger mode rotation of the tool. And let's see if yes, for example, I can change the position of my tool like that, and save this point as my cube waypoint. So like that, I created 3 waypoints. You can then, in this motion program panel, you can see all the properties related to those points. But now we will move to creating the motion. So we have 3 points in the space, and we want to define a movement of my robot. So we will make sure, for example, that when we start, we go to the home position. So I can use this move J, which is a free movement of the joints of the robot. Then from my own position, I will go linearly, for example, on the top of my cylinder. So I will move L, so linear movement, to my cylinder point. And in here, you can also define how fast you want to move. I keep it 100% speed. It's fine. From the top of the cylinder, I want to go to the cube, but this time I want to move in a circular fashion, going back through my own position and then down to the cube. So I can use my move C circular instruction. I'll take my home position as intermediate point and my cube as destination. So very simple motion program. I can show that motion on the work cell by displaying the path and refreshing it. So we see the linear motion and then the circular motion down to the cube side. And I will also activate my loop mode. So it will keep repeating this motion once I simulate. To make sure that my movements are correct, I can also, while in addition, I can run some of the actions or the entire motion program. So let's run, for example, the action of going back to my home position. And let's see also a full preview of the motion program. So here I'm still in addition. We will see each step highlighted. So we see the arrow indicating which point I am. The movement is slower than what will be in simulation, but it lets me verify basically my program. Okay, so let's go and start the simulation. So here we have the robot moving in my work cell, and we see that it's respecting my instructions. From the simulation, I can also extract some information like the robot joint angles. So to do that, I need to create a plotter, and I will use my 3D manager. So in the 3D manager, you have the list with all the bodies in the work cell, so my loads and my robot. I can now on the robot we see we have the tool as well. I can take my robot from there, my robot component from there, and drag it on my plotter. And for example, let's plot the first 3 angles. If I run this simulation once again, we can see, if I zoom a little bit maybe on the y-axis, there we go. We can see the motion of the different joints. For the robotic workshop, we also have a online catalog available. So let me open it and bring it over. There we go. And the catalog we now at the moment we have is the Mitsubishi robots. So you see we have a 4-axis Cara robot and a 6-axis robot as well. So in here you can select a model, and like most of the catalogs, you can do a configuration of the product. And then if I collapse this section, I can take this symbol from the online catalog and drop it in my work cell. Let's place it over there, for example. So I have my specific robot ready to work in my work cell. I will now open another demonstration file in which we can see a couple of robots operating together. So let's give it a moment to load. There we go. So here I have my work cell. We have a conveyor on the work cell floor. We have a couple of loads moving on that conveyor. you see the movement path for my 6-axis robot is displayed at the moment in green. And here I have this element, which is a sensor. You have it here in the library, which once the box passes through the sensor, it activates my first SCARA robot to place the box in the right position, and then my 6-axis robot will cover its path. So if I run my simulation, we can see the two robots working together on this simple conveyor. So the box goes through my sensor, it activates the first robot, and then the second robot does its work, and so on. So you see how the robots are placed in the work cell. To activate them, so there are some input and output variables. We see this SCARA robot will receive an input on this variable to start its motion program. Indeed, if I go check in here, I have my input one that received the signal from the sensor. And then in order to pick up the box, if I go in my motion program, so for my SCARA robot, I can look in the motion program, and there are some do actions that are corresponding to take the box, release the box, and so on. We see also there are some wait times, and so you can use the different commands to create a wait time or an action. So this concludes the presentation on the robotic workshop. We can now move to the next part of the webinar. Thank you.
Thank you, Luca. Okay, so remind you guys again, everybody who's connected, if you have any questions, you can put them directly in the questions box on your side. We'll be going through that now just to see if there's any questions that we can go through. Okay, maybe we'll start with some of the questions related to P&ID, and then I'll talk about we'll go through the robotics after. So first question for you, Jose. Is the P&ID module available in all versions of Automation Studio?
Yes. Yeah, so the P&ID version is just I would say a bit on the license that is added. So it's available, or can be available, I would say, in educational version and professional version of Automation Studio. But now there is the way of how that is distributed. So that would be more of a question for you, Bruno. So it's part of a package or not? That I don't know.
Yeah,
but it will be available. It can be available in every version.
Yeah, exactly. It's not sold in for everybody who knows. It's an additional module that can be added to to license of Automation Studio. So if you have if anybody's interested in looking into that, just contact us and we'll put you in contact with the right people. Or if you have a technical sales representative, just contact them directly. Good. We have a second question here. Is a symbolic library of P&ID compatible with other documents?
Can you repeat the question, please?
Yeah. Is the symbolic library of P&ID compatible with other documents?
Yeah. Yes. So let me show it in the screen again. I think I did it during the presentation, but I don't mind doing it again. Can I share the screen back? Yes. Yeah. So as I said, so let me create again a new project from a template. So the template here, this is contains basically a PNID document. So the PNID document, it's compatible with the PNID library, of course, but also supports other for-specific technologies. So for example, I can grab a PNID item and it will be here, no problem. But I can grab a hydraulics component, add it here. I can grab pneumatic and it will be compatible. I can grab any mechanical object from the library of drive and transmission elements and add it here, no problem. And then the environment and control. So this would be, for example, for you to generate signals and what have you, embedded into the set schematic. Now, the other way around doesn't work. So for example, if I have a standard diagram, which would be your typical fluid power diagram, so this supports PNID, supports hydraulic, pneumatics, and what have you, but doesn't support PNID. So if I try to add a PNID, I get an error. So again, so the PNID, it's a separate module, so it needs its own document, and it supports the PNID library, of course, and a selection of others.
Very good, Jose. Okay, that seems to be the questions that we have for PNID, at least for now in the chat. We have a couple questions on robotics, so I think we'll move on to those ones. So we have a first question. Well, here is the robotics workshop part of the educational version, or do we have to pay extra for it? I'll answer that one maybe directly. So the robotics workshop is an additional module of Automation Studio. Depending on the package that you have of the software, it may be included, but you'll need to talk to your sales representative just to get in touch with them and see if it's something that's already available in your license or not. Yeah, and it is an additional module. The software so normally wouldn't be in any default package of the software, but your technical rep would be able to give you more information on that based on your license. We have another question here. I see there's an import part button. So can we import a part in the robots workspace and have it interact with it, integrate it in the program?
Yes, like always for the 3D environments in Automation Studio, you can import a part. The robotic workshop uses the same 3D engine, let's call it. So the 3D environment is the same as the generic 3D diagram of Automation Studio. So yes, you can import an object and have it placed in the 3D environment. I don't have any 3D object right now, but if I just show my screen once again, because there you go. So these yellow fences, I think they were imported in the demonstration file. So those have been imported as step or STL parts.
Okay, great. We have another question here. Are there any files like the one you showed available to download? Some pre-made systems we can download?
Yes, well, since I have the presentation, I'll go ahead. So if you go on the FAMIC Technology website, under the Automation Studio downloads, if I remember correctly, here you have a list of demo files. So this is true for basically all the different workshops. So you see you have some virtual train, electrical, PLC, hydraulics, and so on. And if I click in over there, I should get the full list, because well, in these thumbnails here we don't have robotics, but there should be also robotic files. The two that I've shown come from are available on the website, I'm sure about that. So there you go, robotics is over there. So here you have plenty of demonstration files that FAMIC has created over the time. And if I filter just for robotics, so this is one that I've used, that's another one, and there you have other examples.
Great, thank you, Luca. If we have different robots, if we have different robots than you have there, how can I configure my own?
Okay, so at the moment, there is no robot configurator. So at the moment, the robot you have is only the one in the library. We do have an internal configurator. That is what we used when I showed you those coming from the online catalogs from Mitsubishi. So all the dimensions and so on are configured. We plan to release the configurator for the users later on. It's not ready yet for public use. It's only an internal version at the moment, but we will release probably later on the configurator for the robot, so everybody can configure its own robot dimensions and geometries.
Okay, very good. And I think we have one more question here. How did you create the conveyor?
Yes, let me go back in here. So I have some space. The conveyor is it's an automatic feature here. You can choose if you want. Well, you have here the linear conveyor in the library, but the really nice one is the conveyor path. So you can start by, for example, clicking in the work cell, and let's see if I'm able to do a full circle there. Didn't like the closing, but you can define the path of the conveyor by simply using this tool and clicking. I use the grid points. You can use points that are not on the work cells grid, or change the grid space on the spacing on the floor. But this way you can create a conveyor with a defined path.
Okay, thank you, Luca. So I'm looking over. I don't think there's any other questions that that have been posted in the Q&A. So I think that'll be concluding it for today. I'll just take back the screen really quickly just to conclude this. You should see my screen. Right. So I wanted to just thank you guys. Thank you all for attending again these webinars in Automation Studio. So this concluded our third and final webinar for this series on the webinars for what's new in Automation Studio 9.0. So again, all the videos will be available to all registered participants, and also will be posted on FAMIC Technologies website as well as our media outlets. So again, thank you all for attending. Have a great day, and we hope that this webinar has been informative for everybody. Bye-bye for now, and until next time.